Greetings everyone, this is Kushal here from Purple Trades, and today we will talk about our first lesson in advanced option module. We will be learning about several aspects that affect option premium and how one can use statistics and probability in their favor while trading in options. We were supposed to start learning about Black-Scholes calculator, but while creating this content, I realized we will have to first learn few basic topics before jumping to Greeks. So here is today's topic list that we will be learning in detail. So today we will be learning about introduction to option premium, impact of premium on option valuation, what is standard deviation, and normal distribution curve. Now before I start explaining these concepts, if you are absolutely beginner and have just started trading, this and few upcoming videos will be very difficult for you to understand, and if you want to consider skipping all of this video, it's completely okay, you can skip it. But yeah, if you're already trading in option for more than a year and you're finding it difficult, then learning this Greek factors would give you a better edge to understand how option premium works. So without wasting much time, let's get started. Let's first talk about pricing of derivatives. Now we have already seen in our previous lessons on future that the future pricing is decided on continuous compounding method. If you remember from our classes on futures, I have given the formula that future prices are derived by the following formula: F is equal to S into E raised to RT. We have already covered this in our previous lesson on futures, where F is future price, S is spot price or equity price, E is nothing but exponential, R is risk-free rate of return, and T is time till expiry. So when we talk about pricing a derivative, the derivative is priced using continuous compounding method. And now these are the following things that you need to understand before we go ahead. Now in our previous class on future also I've explained you this, that R is nothing but risk-free rate of return, and because of risk-free rate of return, the future prices are greater than spot price. We have already spoke about why futures have premium. Now bigger this risk-free rate of return, the greater the RF, greater the difference between future price and spot price, and greater the probability of stock going up. The probability of stock going up and down is never 50-50. The probability of stock going up and down is never 50-50. It is always 50% plus risk-free rate of return and 50% minus risk-free rate of return. So greater this RF factor, greater the probability of stock going up, or smaller the risk-free rate of return, smaller is the probability of stock going up. Now moving ahead, when we talk about option premium, the option premium is also made up of two values. This is also what we have covered in our last videos. It is made up of intrinsic value, that is the difference between current market price and strike price, and extrinsic value, also called as time value. Now we have already studied that intrinsic value is nothing but the difference between current market price and strike price, whereas extrinsic value is made up of several factors. Now these factors are delta, gamma, theta, vega, rho, implied volatility. All of this combined itself is called as option Greeks. So option Greeks is nothing but the factors that combine together to form time value or extrinsic value. So we will be learning in detail what exactly constitutes in time value, how understanding Greeks can help us get a better edge on our option understanding. Also, before we move ahead, remember a small note. I hope you already remember this, that only in the money call and put will have intrinsic value. That means intrinsic value is only in the money call and in the money put. Apart from ITMs, at the money and out of the money will be only made up of extrinsic value or time value, that is they are only made up of combination of option Greeks. That's it. Similarly, in the previous classes we have also saw that if a stock goes up or if any script goes up, the corresponding call goes up and put goes down. Also we have seen that if a script goes down, corresponding call goes down and put goes up. Now before we discuss Greek factors in detail, we need to understand why exactly call goes up, put goes down. Apart from stock going up or down, there are a lot of other factors that influences a call or a put to go up or down. Let us first understand them also in detail. So these are the factors, or these are the parameters that affects the stock price, the premium price of call and put. So if any of these parameter goes up, they will have corresponding effect on our options. So let us understand all of them one by one. First of all, exercise price or strike price. Now suppose, say if the stock price is 100 rupees, if the strike price is 105 or 1110 or 115, as the strike price will keep going up, the call price will obviously keep going down and the put price will obviously keep going up, because call will become OTM and put would try to become ITM, right? So as the exercise price or the strike price goes up, call will go down and put will go up. But if the spot price or if the stock price goes up, call goes up and put goes down. So if the spot price goes up, call goes up and put goes down. And if time to expiry goes up, that means if we have a lot of time till expiry, we know that both call and put will be up, because as the time is consumed we have premium decay, but if we have more and more time, premium stays higher and higher. Similarly, volatility, it is also called as IV, right? So we will talk about volatility in detail, but right now what you have to understand is that if volatility is high, then both call and put value will also be higher. IV plays a very important role in option pricing. We will talk about IV also in detail. And then interest rate, that is nothing but risk-free rate of return also. We have just seen a minutes ago in this video itself that if RF is high, then probability of stock going up is high. It is 50 plus RF, so call will be higher and put will be lower, because it is 50 minus RF, the probability of stock going down will be low. So if higher the risk-free rate of return, higher the prices of call and lower the prices of put. Similarly, when we talk about stock dividend, whenever a dividend is announced, market falls by so much of points. Suppose, say a stock of 100 rupees announces a dividend of 2 rupees, stock is expected to fall by almost 2 rupees. If it is announcing a dividend of 5 rupees, stock is expected to fall by 5 rupees. So higher the dividend, more the fall will be in the call, so the call would go down, and the higher the fall, the put would go up. So if the stock dividend goes up due to market falling down, call would go down and put would go up. So apart from spot price, these are the various other aspects that impacts on the pricing of options. So to summarize, strike price, spot price, time to expiry, volatility, interest rate and stock dividend, these are the factors that affect calls and puts in the following respected ways. So now that we know what factors drive premium price, the next topic that we can discuss is normal distribution and standard deviation. So if I talk about normal distribution, well, normal distribution is a probability function to describe the symmetric distribution of values. Now I'll talk about this in detail. So basically this is a bell-shaped curve where you have mean is equal to median is equal to mode. Now this bell-shaped curve is basically the number of times a particular price or a particular range of the price is hit when the stock is randomly moving up or down. Now every stock goes up or down by a certain percentage. Some are stable scripts like index, which moves only 1 or 2%. Like if you talk about Nifty, they hardly move 1 or 2% on normal days. On very rare exception days, they move up or down by 5 or 10%. But there are some stocks, some penny stocks, which move up or down by 5 to 10% every day. They either hit upper circuits or lower circuits on every day-to-day basis. So different stocks have different volatility. Some stocks have low volatility like index, and some stocks or some scripts have high volatility like options or penny stocks, which move up or down by 5 to 10% on an everyday basis. Now since they have different volatility, the curve for these particular stocks will also have different volatility. Now I want to explain you what this normal distribution curve means. Now suppose say if I were to mark the movement of index, let us say Nifty, depending upon how many times it is going up and down. If this is a graph and x-axis represents percentage move in a single day, right? So let us say 0 to 0.5% and 0.5% to 1%, 1% to 2%, or say 2% to 3%, 3% to 4%, so forth and so on. So we'll see that if there were 100 trading days, then at least 10 to 12 trading days we had 0 to 0.5%, then around 40 to 50 trading days we had 0 to 1%, then around 30 trading days we would have 1 to 2%. Very rarely you will see stock going up or down by 2 to 3%, maybe say around say 12%, and if I had to talk about 3 to 4%, it can be say 0. This is 1%, 2%, 3%, 4%. This is -1, -2, -3, -4. What you will see is the highest times the Nifty has moved is in between 0 to 1%. So I can write say 40 times, and then 30 times in 1 to 2%, be it positive or negative, then 12, and the curve keeps falling down. So the symmetric or the normal distribution curve would grow something like this. So a normal distribution curve telling you that the center point has the peak. That means the highest time the market, highest way the Nifty is moving is 0 to 1% or 0.5 to 1%. Now similarly, if I talk about options or any other stocks, they move they will hardly move 0 to 5%. They would be moving 5 to 10% quite often, 10 to 15% quite more often, 15 to 20% quite more often, so forth and so on. So instead of just staying between 0 to 5 or 6%, the range would be infinite. Someday options can move 100% up also, or become 100% down also. So their graph would be quite wide. It would be something like this. They would have a quite wider graph, right? So if the graph is very wide, it will not tell you what is the major time or what is the peak point where highest number of transactions are occurring. However, if the graph is very narrow, then it would tell you that at the centermost point the highest number of transactions have occurred. Now this is the importance of normal distribution curve. Now if you see any blue chip stocks like Reliance, Infosys, Wipro, TCS, they all have very narrow bell-shaped curve where it indicates that on an average these blue chip stocks moves up or down by 1 to 2% only, right? And this helps us understand which strike to choose, what is the best probability, and which strikes would be optimum to trade. I'll explain you how. In normal distribution, mean is equal to median is equal to mode. That means first, if you have to understand the definition, mean is nothing but basically the average. So if you have, let us say 10 numbers, A, B, C, D, 10 numbers, you simply add all of them and divide by 10, you will get a average. Now median is nothing but the centermost number. So for the centermost number, you just put all the 10 numbers in the ascending row and you pick the middle one. That becomes your median. And for mode, in a row, if a particular number is occurring again and again, that becomes your mode. So we know that if in a bell-shaped curve, at the center, this center point would have occurred again and again. That is why the tip is the highest at the center. So mode is equal to the center number, that is nothing but mean, and if it is in the ascending order, has to be also equal to median. So mean is equal to median is equal to mode, And now when a curve is formed, we also find a factor called as standard deviation. Now what do you mean by standard deviation? Standard deviation is basically a number by which all the other numbers are ahead or behind by, or basically I can say that this is an average number by which all the other numbers are up or down by. For example, consider that in a test the passing marks is 33%. Now let us say there are 10 students, 1 2 3 4 5 6 7 8 9 and 10. One guy has scored 87, other guy has scored 72, other guy has scored 64, one guy has scored only 22, one guy has scored only 10, so forth and so on. So let us say this is my reference point. From this reference point, 87 is above by certain number, 72 is above by certain number, 64 is above by certain number, 22 is down by certain number. So this I can say is my current standard deviation or my reference point. From this reference point, every individual is either up slightly or down slightly by a certain point. Now standard deviation is calculated depending upon how much stock is going up or down. For example, on few days going slightly up and few days it is going down, down, up, down, right? So if I have to calculate the entire move and calculate an average, there would be certain average. Let us say I'll represent it by say dotted line. From this particular dotted line, every day the stock would have either gone up by certain percentage and down by certain percentage, right? So that is my standard deviation. Now how do you calculate standard deviation? It is almost as good as calculating the average of the entire move. How do you calculate? Let me give you an example. Say on 5 days, we have taken 5 days move of a particular stock. One day the stock is moving up by 2%, other day it is going down by 3%, other day it is going up by 4%, then next day it is going down by 7%, up by 9%, so forth and so on. I have this 5 days move. Now if I have to calculate the standard deviation, first I will add all these numbers and divide by 5. 2 plus 3 plus 4 plus 7 plus 9. Divide by 5. So average comes down to 5. So that means on an average the stock is approximately moving up or down by 5%. Now to calculate standard deviation, I'll subtract 5 from all this percentage. That means on first day in an average the stock was supposed to move up by 5%, but it moved only 2%, so it did not go up by 3%, right? Second day 3 minus 5%, it was missing the mean by 2%. Next day it was missing the mean by 1%. Next day it was going above the mean by 2%, and next day it was going above the mean by 4%. Now the values are in negative and positive both. To remove the negatives we will square off, so we'll just square it. So the square of 3 would be 9, this would be 4, this would be 1, this would be 4, this would be 16. We square to also make sure that small numbers add smaller value and big differences will add bigger values. If I combine all of this and divide by 5 again, I will get an average of 6.8. Since I have squared, I'll just square root again because last time I did a square, right? Now to get the true value I have to square off. So if I square off, the value comes to 2.6. Now 2.6 is a standard deviation. That means after 5th day, from 6th day onwards, the stock can move up or down, where 2.6 is the one standard deviation unit. No matter how much stocks go up and down by, 2.6 will become my 1 unit. If the stock goes up by 2.6%, I say that stock has moved by 1 standard deviation. If the stock goes down by 2.6, I say stock has gone down by 1 standard deviation. Now if I have to represent all of this again in the normal distribution curve, I'll explain you how it works. So when I draw a normal distribution curve, center is your 0, then 1 represents 1 standard deviation of a particular stock, -1 also represents 1 standard deviation, then 2, then 3, then 4, so forth and so on, 2 and 3. So what you will see is that the major portion is covered in one standard deviation, +1 and -1. This entire area sums up to 68.27 part of the entire curve. Now if I have to take standard deviation 2 and 2, it covers more and more area, right? It covers approximately, this much area covers approximately 95%. Now standard deviation 3 will cover say 99.73%. so major portion is covered in 3 standard deviation, and 4, 5, 6 will give you very small standard deviations. Now why is this important? Why am I teaching you all this? I'll explain this to you. So this is what 68, 95 and 99% rule looks like. One standard deviation, nu represents median, right? From there sigma represents standard deviation. One standard deviation up or down, you cover 68.2% represented in pink line. 2 standard deviation, you cover 95.45%. 3 standard deviation, you represent 99.73. Why are we doing all this probability? Is to understand what is the probability of stock going up or down. And why is it important when we trade in options? Let me explain you. Assume that Nifty, you are calculating on based upon weekly contracts, weekly closing price. So let us say this week Nifty closed at X price. Let us say X price. Next day it closed, next week it closed at Y, Z, so forth and so on. What you're observing is that on an average in a week Nifty is going up or down by 3 to 4%. Some days it is going, some weeks it is going up by 4 to 5%. Some weeks it is going down by 5 to 6%, so forth and so on. So you have collected, let us say, around 100 weeks data, and you have calculated a standard deviation. Now you get a standard deviation, let us say, as 4%. So 4% move up or down is your standard deviation. Now let us say Nifty has moved something like this, and currently we stand here. Now if I have to predict the probability of Nifty going up or down, we know that one standard deviation is equal to 68.2%. That means from whatever point, let us say if the Nifty is at 10,000, from 10,000 it can go up by 4% or down by 4%. The probability of Nifty staying in this curve is 68.27%. So it can be 10,400 or 9,600. And if I take 2 standard deviation, that means 400 points more up or down, it would become 10,800 and 9,200. So Nifty staying in this range, the probability is 95%, and 3 standard deviation, that is 11,200 and 8,800, the probability of Nifty staying in this region is 99%, and it makes a lot of sense. Now if you are very conservative, and if you want to make sure your trade is winning around 95% of the time, what you can do is you can go ahead with 2 standard deviation. You can sell out of the money call and you can sell out of the money put, and there are 95% chances that it would stay between 9,200 and 10,800. And if you short 10,400 call and 9,600 call to consume premium decay for a week, there are 68% chances that the stock will stay in this region. So this is the benefit of standard deviation and normal distribution curve. Basically they give you a standard deviation, that means by what price stock can go up or down. They will also help you understand which stock is more stable or more flat, because bigger the standard deviation, that means more volatile the stock is, and option writing becomes very difficult in those particular stocks. So I hope you have understood what is the explanation of normal distribution curve and standard deviation. If you did not understand any of this topic, do let us know. You can be a part of our live webinars where you can ask your doubts regarding all of these topics. All you have to do is to open a Demat account with us, and you will be eligible for all the live webinars. And in the next lessons, we are going to talk about Black-Scholes calculator in detail. We were about to talk about Black-Scholes calculator in this video, but then I realized talking about normal distribution curve, standard deviation, and parameters that impact premium pricing is very important for you to get foundation right, and then we can go for Black-Scholes calculator. So as I said, option Greeks series we will be going very slowly. We're only going to talk about Black-Scholes calculator and nothing